Hello everybody. Let me start my presentation with exactly the same words as I did it 3 years ago. So I have to apologize for my condition. I almost lost my voice yesterday. We celebrated the entire night, so I am almost dead. So my colleagues told me that I told this 3 years ago. I don't believe them that I was in the same condition because I will probably die within these 15 minutes. But let me try to present what we did, at least a little bit. I had no time to prepare any slide. Even my slide is not changed, the first slide. I have to do it because, of course, we will replace some pictures from this event. So let me introduce first my group. Hopefully some of you know us already. Our group has been established 4 or 5 years ago with 2 of my colleagues. You can see the first picture above. We are growing a lot, and I have to say that this is mainly because of the MBZIRC, because we got the funding from you at the beginning, and based on our success 3 years ago, we got a lot of other projects. So I have to thank you guys for doing this great job. I have to thank you again for doing it this year. It was really excellent work you did. The organization was really well done this time. I have to say even that was much better than last time. So thank you for the great improvement, and I'm really looking forward to see another improvement in 2 years maybe. The last thing I wanted to mention is that now we are at the MBZIRC, half of my team, and the second half of my team is in doing DARPA challenge in exactly the same days. So probably today they will win DARPA. Hopefully they are on the first place in non-funding teams. They will get $500,000. So we are not so sad that we didn't get it yesterday. Yes, so let's go to the description of the achievement we did. So some of you know that we spent 7 weeks in a desert, which was close to a line. We tested the system there. The reasons were quite obvious. In Prague right now it's around 0, minus few degrees of Celsius. It's raining almost every day, so you cannot fly there. So that's why we decided to come here, testing the conditions of the local climate with the sun you have here, which is very different from sun which is in Prague right now. We have only a couple of hours of sun, and usually there is no sun the entire day. We tested there all the challenges and all the subtasks successfully. Unfortunately, we were not able to show everything during the competition because, of course, the conditions were a bit different. Maybe there was not enough time for testing. So this is maybe the only comment for the organizers. So next time, please provide more testing hours. I know that it's almost impossible or very hard, but this was in my opinion, this was the only thing which the difference between the best or the good performance of all teams would do it much better if they could test it more. And so maybe the challenges were too difficult, but I think this is more important to provide more testing hours, and then even the really difficult challenges would be done by most of the teams, not only by us. Yes, so you can see here a picture of flying the objects, the balloon we did in the desert as well. We were able to spray the water into the target, indoor, outdoor we did it even. The bricks, of course, we have tested long time, quite successfully. The conditions there were a bit different, but we could modify the system to work nicely even here. Yeah, so here you can see how our conditions in desert looked like. We use some stuff. We couldn't transport everything from Prague, so we used the resources that were there for building the mock-ups and infrastructure. Yeah, so this is a video of one of the trials of spraying the water. So we were able to follow this wall and precisely inside the water. During the competitions, we could repeat it during the demo with 2 drones, but during the real competition we scored only a few milliliters. So now I have to tell you how the second challenge worked. So all challenges we did were fully autonomous, of course. We use onboard vision for detection of the bricks. So at the beginning of the mission, the drone was scanning the entire environment, so we didn't use any measured positions for in the first trials of challenges. So the drone measured or estimated the position of the piles, the position of the brick by scanning it. Then it was multi-robot system, so after the scanning, the drone sent these positions, estimated position of the targets to other drones in the team, and 2 drones cooperatively were able to place the bricks. We could do it even with more drones, but the pile and the wall was so small that it worked better with 2 drones than with 3 drones. So the third drone was waiting in the initial position, and once the other drones finished their job, it could be replaced. So the state machine worked like that. After the scanning, each drone got a task to grasp a particular brick of particular color and place it into the place in the wall. So the wall was split into several parts, and each part was solved by one of the drones. So for the gripping, it was a visual servoing, as I said. So there was block color detector and a feedback using it for detection of the particular brick and for the precise control and grasping. The grasping was done by a magnet, electromagnet, and then the wall detection was done by a 3D camera, so we could see how the wall was high. So this is pictures from our attempt of placing the blanket on the ground target. Again, it was fully autonomous. We didn't record the position of the ground target, even we could, but we wanted to make it fully autonomous to really achieve performance which is like realistic one. So the drone was scanning the entire environment, looking for thermal sources, and then making a special maneuver to put the target there. The same was done with the facade fires. Again, the drones were scanning the facade by thermal camera, and once there was a target, thermal target, the drone approached that and combined classical RGB vision and thermal camera to target it precisely. We were even able to fly inside, but we didn't try during the competition because the position of indoor fires were really complicated. As you put it on the bed, it was almost impossible for us to approach it. So if it would be easier to approach it, we could try to fly in. There was also another problem with detection of the closed window, but we could probably solve it. So this was the firefighting challenge. I don't know if I may run this video from the brick detection, so sorry, I wanted to use that for explanation of the vision. So you could see here the brick detector as it works. Was the so watch the upper video, and here you can see the wall detection from the depth camera. So So now the drone is approaching, targeting the wall, so the detector was able even to detect the spacing between the bricks and to detect where it can place the brick. So let me also show you a little bit the last challenge, if it's working, the video, maybe not. Yes, it is. So here you can see a video from the drone popping the balloons. So we used RGB camera to detect the balloons, the position of the balloons, and using the size of the balloons we could approach them precisely. Again, we didn't measure the position of the balloons before by GPS because we wanted to make it as much realistic as possible. So the drone did scanning of the environment completely, and again we could do it by multi-robot system. So two drones cooperatively could destroy the balloons, they could avoid each other by our collision avoidance system, and simultaneously the third drone was searching for the ball. We were able to catch the ball even 3 times during the challenge, all challenges, or maybe even 4 times, I don't remember. So almost in each trial we got the ball, which was also quite successful. I have to thank my colleagues who did it. The approach for catching the ball was a bit different from our Chinese colleagues. We waited in a position for the ball, for the drone coming. We estimated the trajectory of the ball by I forgot the name of the sensor, sorry, but it's similar to Oyster sensor, kind of like a Velodyne. So by this sensor, we could estimate the position of the drone once it was flying the curve, and after estimation of the curve, we could wait in the position and then update it or response to the approaching of the drone and catch it. So this approach was a bit different than our competitors, as I said. Maybe it was a bit more robust, but not so effective. Your approach was really nicely to see. Anyway, let me now switch to the, if I can, yes, to ground robot. So my colleague will show you how the ground robot worked.
So thank you, Martin, for our introduction. My name is Tom Krajník, and I'm from a different department, but from the same faculty. And I actually know Martin very, very long. We did our master thesis together, and it was on robotic soccer, and we remained in these competitions. So this time, since Martin is not doing any robots with wheels, he's only doing these flying robots, he asked me to help with the ground robot. And I fell in this trap, sort of, because I thought, because my primary expertise is on long-term autonomy. So what I do is reliable navigation outdoors, and my robots are able to deal with environment changes. So what we do is that a robot moves around and is able to update and predict its maps and to deal with drastic changes of the environment. And this leads to robust navigation technology. So originally I thought that I will only implement these navigation technologies on the robot, and that will be it. However, when I arrived, I thought that the robot, which was supposed to be ready, was ready, but it had no code inside. So we had to program everything in 6 weeks. So together with the 2 members of my team, I could not have any other members actually, because some of them are at the DARPA challenge, as was mentioned. We took a Husky robot that was brought here. We took an arm that was actually borrowed from UPenn, and we had to program everything from scratch in 6 weeks. So what we did is that we used actually all our expertise from previous projects. So the idea was that for navigation, we will use a customized AMCL from Ross that was customized for the Strength project that specifically dealt with navigation in difficult environments. And you could actually see in these challenges that because of the uneven terrain, many teams had problems because it was not completely flat. But our navigation stack was working quite precisely with this. Regarding the vision systems, we basically used our previous work. That's a very robust and fast segmentation algorithm that's independent of OpenCV. And we tweaked this algorithm to do all the segmentation. So detection of the breaks by the camera and the detection of the pattern by the camera. Regarding the high-level planning, we simply used a state machine where we guessed the points where the breaks could be. And then when the robot was approaching the breaks, it was using simply Ransack to align with the breaks. Then it looked with the camera down to detect the breaks from the depth. And it was very surprising for us that even in this heat, the thermal images, the infrared images were working quite precisely. Then when the robot aligned, we simply run a state machine that was picking up the breaks on top of the robot. And after that, we went to an estimated position of the pattern with the camera raised up, so we could really see very, very far. And in the first attempt, we had a small problem with the state machine, but that was then removed. And then the robot was able to detect the pattern, and it was gradually lowering the camera, then aligning with the pattern, and then just landing the break. So out of these two algorithms and one extra algorithm for visual navigation, we were able to smash the system together in 6 weeks. So, one of the main things, as that was stressed by organizers here, is the openness of the system. So if you want to use anything, we actually published all the code that was used on the ground robot on this GitHub repository. It also contains all the links to the original software libraries and the related papers. So if you are interested, go there and you will see how we actually solve the challenge on a technical basis. I have to apologize, we didn't have really time to comment the code properly. Okay, thank you.
Yes, thank you, Tomáš. And let me conclude my talk with some more. Yes, so let me again go back 3 years ago. Lakmal at that time asked us if the challenges should be less or more difficult. I was like after party, so I said make it more challenging. And then I heard this from my colleagues during these 3 years several times because they told me how big I'm an idiot that I mentioned that because it was maybe too complicated. But I'm happy that these challenges were really on the edge of the state of the art. We are now able to publish maybe 10 good journal papers in like about each of the subtasks. We will do it, and so there was a discussion if we have to do this same setup again, for example. Yes, we can, but then we are not able to publish it again because everything will be already published. So of course the performance will be much better if you will stay with the same condition and with the same setup. But I cannot use my PhD students for that job because they would be not able to publish it. So Lakmal, please again make it more hard, and maybe we have decided yesterday to really publish everything we have achieved, to share the knowledge we have with you. Some of you may know that we are doing a summer school in Prague during summer. We have decided to make one of the exercises there really MBZIRC focused. So there will be speakers from talking about multi-robot systems in general, but practical exercise will be on MBZIRC. So if your team members would like to come, we will really give you all the codes, we will give you access to our repository, we will learn you how to use our code, how to use the multi-robot system, because I would like to see in 3 years really multi-robot systems running, which means not only 3 robots in the Grand Challenge, but 9 robots, for example, which I asked several times, but of course I know that resources of other teams were limited, but still we can do it for the next. So the school was done already this summer. It was quite successful, I have to say. We got 120 students last time from all or almost all good universities doing multi-robot systems worldwide. This year we have already announced the first call for participation. We got 80 students right now, but we will make another call mainly because of you, and we would really appreciate if your team members could come, because I think the MBZIRC is also about the cooperation between the teams. We have got a lot of friends here, and I would like to really, sorry for the pork meat there. I know that it's not the best here, and then there is also a little bit of beer, but of course non-alcoholic beer in Prague. Anyway, so here you can see some pictures from the experiments we did. So this is a job of students at the school. So they were able to use within 5 days our system and implement a multi-robot scenario with 2 drones visiting these locations and observing the flags there. So they did it in 5 days. I believe that now we can repeat some MBZIRC scenario for this summer. So thank you very much for your attention, and probably I used my time for questions, right?
Almost, yeah. Okay, but one question, just please. Thank you anyway. Yes. Only one.
I have a question. So, in the first scenario, when the drone is carrying the blocks, if the block is very large, is that a problem because it blocks the camera view, so it's difficult to mount the camera in the right position?
We solved this issue by placing the camera far away from the center of mass of the vehicle. So there was an holder, extended holder with the camera. So it was not any issue for us.
Martin, thank you very much. I appreciate very much that you share the things among your colleagues, and that you like so much the place here, that you come